Welcome to this tutorial on interval estimation for the population proportion. Just as we have created confidence intervals for the population mean with both sigma known and sigma unknown, we can also construct a confidence interval estimate for the population proportion. The general form of an interval estimate is the sample statistic plus or minus a margin of error. For a proportion, that would be as shown here, p bar plus or minus some margin of error. We have seen in previous tutorials that the sampling distribution of p bar can be approximated by a normal distribution whenever n times p is greater than or equal to 5 and n times 1 minus p is also greater than or equal to 5. You can refer back to the tutorial on sampling distributions if you need a refresher on the topic. But for this tutorial, you need to remember that the mean of the sampling distribution of p bar is the population proportion p, and the standard error of p bar is shown as sigma subscript p bar, and that is equal to the square root of p times 1 minus p divided by little n, the sample size. This standard error will now be used in the formula for computing a confidence interval estimate for p bar. Here is the formula for calculating the confidence interval estimation for a proportion. We can see that the standard error is used as an integral part of the formula. We also see that we will be using the z-table with alpha divided in half since the sampling distribution of p bar is normally distributed. So to calculate the interval, we have the formula shown here. P bar, which is a sample proportion, plus n minus z of alpha divided in half, so that is the value we look up in the z-table, times the standard error for p bar, which is the square root of p bar times 1 minus p bar divided by little n. The original formula for the standard error of p bar shown on the previous slide actually uses p, not p.